So, in this video we're going to talk about logarithmic scale. And the reason we're going to talk about this is because at the moment there's a lot of graphs in the various media that you're looking at, and a lot of the graphs have a logarithmic scale on the y-axis. That's this axis here, the vertical axis. And it's important that we understand that scale compared to the linear scale that we would all be more used to and more familiar with. Okay, so the first thing is, whenever you see a graph, you have to check what is represented on each axis. The graph just won't make sense until you are very clear on that. So what I've taken here is this, these two graphs here are from the New York Times, and they represent the number of cases in Italy and the US between these dates. And it's the same information here plotted on two different graphs, okay? So on this graph here, we have the linear scale down the side, which is what you're used to. This y-axis here represents the number of cases in these countries. And you can see here, this distance on this axis is plus 15,000. Goes from 0 to 15,000. And then from here, the same distance again, from 15,000 to 30,000 is another 15,000. And on we go. Okay, same distance again up to this bit here is another 15,000. So this is the linear scale graph that we're used to from number lines that we study from a very young age. Now we need to look then at this graph here. Okay, now here, if you look, it's important to note here that this graph starts at 1. Also, and it goes to 10. So when you go from 1 to 10, and then from 10 to 100, the same vertical distance along this axis, and the same again to 1,000, you ask yourself, what's happening here? Well, we're not adding as we go up here. It's clear here that to go from 1 to 10, you can multiply by 10. To go from 10 to 100, you multiply by 10 again. And from 100 to 1,000, you multiply by 10 again. So distance on this axis is a certain distance, any distance, in this case this length, means that you're multiplying by 10. You're not adding like you would on a linear scale. You're multiplying by something. So if you move a smaller distance, you're multiplying by some smaller number than 10. Okay? So just to prove to you that these two graphs do represent the same information, we'll just take a random point just to illustrate. Okay, so if we take, okay, so let's go over to this logarithmic scale. And we're going to take this random point here. So if I drop a line down from here until I hit the x-axis, what is this line telling me? Well, this is telling me that on this date, which is, we have the 19th, 18th, 17th, 16th, 15th, 14th, 13th, 12th, 11th, 10th. So this here is the 10th of March. Okay, on March 10th, in the US, there was this many cases, 1,000 cases if we go across, roughly 1,000 cases. And in Italy, on the same day, March 10th, we go across from here, we can see that they had roughly 10,000 cases or just over. Okay, so now let's go to March 10th on the linear graph here, which is representing the same information, just with different scale. If we go to March 10th, so 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, that's here. If I go up here until I hit both curves, we can see here, if I go across for Italy, if I go across now to my vertical axis, it looks like I'm roughly 2/3 of the way up this distance from 0 to 15,000, roughly 2/3, which would be about 10,000, which is this number that we get here for Italy. And also if I go from the US across to here. You can see that this number here would be somewhere in the region of 1,000, which is the cases for the US on March 10th, was 1,000 cases. And here, the US on March 10th is about 1,000 cases. Okay, so you can see that you can do this at any point on the graph and you'll see that the information is the same. The only difference between these two graphs is the y-axis. The y-axis. The x-axis is the exact same as you can see from February 18th to March 19th, but the y-axis in a linear graph means you're adding a certain amount as you move up, and with a logarithmic scale you're multiplying by something as you go up. We'll do another video to explain in detail what happens in this scale between values as well.